Hi everyone, and welcome to an introduction to Calculus Lesson 4 or 5, which is the substitution rule. This is also sometimes called u-substitution. So if you're doing an internet search for something about this, probably you will find it under u-substitution. Now, there are several steps that we use, and once you start practicing these, you realize that they are rather intuitive as you're going through the question. The first thing you do is you identify the inside function and label it as u. And the reason we do this is because u-substitution is used to find the integral of something where the chain rule would have been used to get this function. So we're getting back to our original function, we're undoing a chain rule. So we have an inside function, we have the derivative that was multiplied, so it's like undoing that chain rule. Okay, so we first find the inside function. My inside function happens to be, in this case, x cubed plus 1. And sometimes it's very, very obvious what the inside function will be, and sometimes it's not. So my suggestion would be to simply try something if you're not sure. See if it works. If it does, good. If it doesn't, go back and try something else. Okay, so this is my inside function. I'm going to label it as u. So I'm going to say u equals x cubed plus 1. I'm going to ignore all the other stuff here for now and just focus on this u value I found. It says find its derivative and be sure to note du and dx. It's really important because what we're going to do is we're going to find this derivative and we're going to substitute parts of it back into this. So I'm going to find the derivative. Du is 3x squared dx. Now, notice we're going to look for this in our original integral. So I notice that 3x squared dx matches this and this perfectly. Okay, everything here is accounted for up here. So what I'm going to do is I'm actually going to substitute these pieces out and make them into a du. So my integral is going to change what it looks like. The blue underlined things are going to be a du. The green underlined thing, remember, that was our u right here. U equals this x cubed plus 1. So I'm going to put that there where this x cubed plus 1 was, u. And don't forget that was to the 6th power. Now, this is an integral that we can find pretty easily. Okay, we just use the power rule. I'll go up by 1 on the 6 to get a 7. And then remember, we divide by this new exponent. And don't forget the plus c because this is an indefinite integral. We need the plus c. So that's step 4, and step 5 is that we want to substitute back in the original expression. Our original integral was of expressions with x's. This has a u in it. That's bad. We need to go back to our original terms. So I have 1/7. Now this u is the same thing that we had up there. Okay, it's x cubed plus 1. So I'm going to replace it with x cubed plus 1. Don't forget that this is to the 7th power, and it's plus c. Okay, so we look for the inside function, substitute it out using a u value, do the derivative, look to substitute back in, do the integral, and then substitute again. So it seems rather complicated, but with practice it isn't so bad. So let's do another example. Okay, this example, the u derivative is not going to match exactly with what's in our integral, but that's okay. We can fix that. So I have the integral of 2x minus 5 to the 10th dx. Okay, so notice the inside function is pretty easy to see again. We have this 2x minus 5 right here. So that's going to be what I'm going to use for u. U is 2x minus 5. Okay. So now I need my derivative. Derivative of u is just du. Derivative of 2x minus 5 is 2 dx. Okay, so now I've done my derivative and I want to substitute back in, but notice the problem. Dx is here, but there isn't a plane 2 anywhere here that's not part of my u. So what I'm going to do is I'm going to get dx alone. I'm just going to divide by 2 on both sides of this expression to get 1/2 du equals dx. Now I can substitute. Okay, because the dx does show up in my integral. Here's dx and here's dx. So I'm going to replace that dx with this whole thing. So my integral turns into the integral of u to the 10th times 1/2 du. Now this 1/2 is just a constant. You may recall from your properties of integrals that this can be moved to the outside of this integral. So I'm going to go ahead and do that. Now I can just do the integral. Go up by 1 on your power, divide by that power. Don't forget this 1/2 that was here, and it's plus c. Now I'll just do a little simplifying. This is 1/22. This u was 2x minus 5 up here, so 2x minus 5 to the 11th and plus c. Okay, so that's my final answer. And I have one more example for you. This one's going to be a trig example because those can always be a little challenging. Let's take a look. I have the integral of sine cubed x cosine x dx. Now remember, we don't have a product rule for integrals, so we're going to try using our u substitution. Now notice, sine cubed x is the same thing as writing sine x to the 3rd power. So that sine is our inside function. So I'm going to say that u equals sine x. Okay, now I have to do the derivative. Derivative of u is just du. Derivative of sine is cosine x dx. Now just be very careful with sine and cosine. It's always very difficult to remember when you put the negative, when you don't. I promise that the derivative of sine is plain cosine. There's no negative on that. Now notice, we look to see our substitution. Cosine x right here is the same thing as what we had here. So I can just replace that with my du. So my new integral, and I forgot to underline here with my u. Okay. My new integral is going to be the integral. This is going to be u cubed, and this is going to be replaced with a du. Now I can just go ahead and do the integral. Go up by 1 on the power, divide by that power, and plus c. And now I'm just going to substitute back out. So I have 1/4 times sine x to the 4th plus c. Now you can also write this as 1/4 sine to the 4th x plus c. Both of these are acceptable notations for that, but those are the correct answers. Now I have one that you're going to try. Put this in your notes. See if you can get the answer, and we will review it when you get to class. So you're going to try to find the integral of x cubed cosine of x to the 4th plus 2 dx. So try to find that integral and bring it to class with you, and we will go over it.